Today we'll be looking at an emergency radio location beacon. Now, I must stress that setting one of these off illegally is a serious crime and they can be quickly and easily traced by the Coast Guard and related agencies as well as Ofcom. They are not toys or gimmicks, they are a serious piece of safety of life equipment. Here we have an example of the Tron 1E Mark II by Jotron, a company that develops, manufactures and markets state-of-the-art communication products and systems for land, sea and air applications worldwide. It's an analogue siren-based emergency beacon for use strictly in emergencies only. It was developed for personal use on board small vessels and was approved by the Department of Trade and Industry in England. Radio plays a large part in safety while at sea. Passenger and cargo vessels must carry safety of life equipment such as EPIRBs, which stands for Emergency Positioning Indicating Radio Beacon. These are optional on privately owned boats, however many carry them should they get into trouble. When one of these devices is activated, signals are transmitted on certain distress frequencies. Satellites monitor these frequencies and positional information is transmitted to control rooms around the world, alerting local Coast Guard organisations to launch search and rescue missions. A helicopter is usually scrambled and flies to the general area from which the signal is thought to be coming. Once the signal, which has a distinctive audio characteristic, is received from the device, direction finding equipment in the aircraft is used to home in on the signal. Finding a stricken vessel in open sea is fairly simple. However, should it be an accidental activation or a fault coming from a vessel moored in a marina with many others, things become more difficult. The helicopter is unable to identify which vessel the EPIRB is on, especially if they're close together. When this happens, they contact Ofcom with a request to help them localise the signal, find the device and disable it. As Ofcom officers approach the area, vehicle-mounted direction-finding equipment is used to try and reduce the search area. However, for the final pinpoint location, they usually have to resort to the use of handheld equipment, directional aerials and plenty of footwork. Locating these devices is important for two reasons. Firstly, the transmitted signal may mask a real emergency, and secondly, the owner of the device will likely be unaware of the accidental activation and therefore won't know the battery will be flat should they need it in a real emergency. The Tron 1A is made with a double switch system to prevent accidental operation. The device is also able to be programmed with Morse code, but approval must be given from the authorities in respective countries. When used in an aircraft, the range is advertised as 50 to 100 nautical miles depending on the aircraft's altitude. However, if the aircraft has been crashed or ditched, the range may be considerably less. If used from the sea, it must be kept vertical so the antenna is above the water. If the device is under the water, a search party will not be able to receive the signal. This model transmits on 121.5, an international emergency frequency with an ERP of 100 milliwatts during the first 24 hours of use, and this depends on the quality of the battery inside. The housing is made of aluminium and the radio comes with a mounting bracket and a helical stubby antenna. To activate the beacon, it must be taken out of its bracket so the locking pin can be removed. The control switch then needs to be put into the on position. To stop it, you have to turn the switch off and replace the locking pin. The device does have a test procedure enabled by pressing the switch onto the test position. The indicator lamp under the top lid of the beacon will then flash. Analog siren-based distress beacons are no longer being used as the main signal, but instead as a supplementary homing signal in modern digital radio beacons. Distress radio beacons include PLBs, ELTs and EPIRBs. When analog distress beacons were used, many false alerts were made, and confirming if the alert was real required multiple confirmations of reception of signal and triangulation of the signal's location. Since the sirens were almost anonymous, it made identifying what was to be looked for difficult, for example a boat, plane or person. The newer digital radio beacons on 406 MHz solve this by transmitting data that includes the registration information as well as the GPS location of the radio beacon if GPS is enabled. Old analog-only distress radio beacons have now stopped being manufactured and are no longer recommended for use. Search and rescue satellites have stopped monitoring the 121.5 and 243 MHz frequencies, instead only monitoring the new 406 MHz digital distress signal band. Although analog radio beacons are now defunct, the analog radio beacon siren is still being equipped on many digital beacons as a supplementary homing signal transmitted on 121.5 and 243 MHz for military use, which are still consistently listened to by search and rescue stations. So that is a look at analog radio location beacons, quite an interesting little device that could just save your life.